Welcome to this video tutorial on probability and calculating simple probabilities. You can pause this video at any time if you want to recap, or if you want to try taking the next step before I demonstrate it, or if you want to use this demonstration as a model to guide you through a different problem that you're solving. So this problem is based on the textbook example in the Applied Statistics textbook, problems 2a, number 4. And the problem reads, a coin is tossed and a die is rolled. The following events are defined. H, the coin shows heads. S, the die shows a 6. Calculate the probability of each of the following events. Part A, H, part B, S, part C, H and S, and part D, H or S. Now, even if the events were not defined, we would define them and we would use a letter to represent them. That's already done for us in this question. So if it's not already done for you, always begin by listing all the events of interest. So we have H, the event the coin shows heads, already defined for us here. And we have S, the 6 shows a die. So if that wasn't included in the problem, we would do that ourselves. We would define those events if the question was presented in a narrative form and didn't define the events. Now let's also identify the probabilities of these individual events. So the probability of a head on a coin toss is 1/2. And while we're involved with it, let's also take note of the probability of not head, because that's something that we may need as we go along. And that's 1 minus 1/2, which is also 1/2. So when we need to refer to heads, we already have the probability outlined there, so we have less to think about. The probability of a 6 on a die is 1/6. Because there are 6 sides that are equally likely, only one of which is 6. And in case we need it later, the probability of not S is 1 minus 1/6, which is 5/6. So I suggest you would always begin a probability problem by doing this. If the events are defined, go ahead and write out their probability and the probability of their non-occurrence. If they're not defined, define them and then do this. And when you're defining events, use a single letter if it's not already done for you. Now, part A of the question asks, what's the probability of head? Well, we've already done that. The probability of head, I'll just write the answer here again. Probability of head is 1/2. There's one head and there are 2 equally likely outcomes. Part B asks the probability of a 6. And again, the probability of a 6 is 1/6, since there's 1/6 out of 6 equally likely outcomes. That's obviously the easy part. Now let's try part C and part D. Part C asks us the probability of head and 6. Probability of head and 6. Now the word and suggests multiplication, provided that the events are independent. That would mean that if a head occurs on the coin, it does not change the probability of a 6 occurring on the die. Well, that is true. These events are independent. Therefore, we can replace the and with multiplication like this. So the probability of H and 6 is the probability of H times the probability of 6. Probability of H is 1/2 times probability of 6 is 1/6. 1 times 1 is 1. 2 times 6 is 12. 1/12. So that's our answer to part C. So we applied one of the simple rules of probability, and we were careful when we were doing so to check that the condition was fulfilled. Now, going on to part D, probability of H or 6. The word or suggests addition, provided that the events are mutually exclusive. Are these events mutually exclusive? If the head occurs, is it possible that the 6 would occur at the same time? Well, actually it is. These events are not mutually exclusive. It could happen that when we toss a coin and roll a die, it could happen that we'll get both a head and a 6. So these events are not mutually exclusive. So our instinct of applying the simple addition rule is not okay in this case. We can't do that. So we'll have to think of an alternative way to do this. Probably a head or a 6, either a head or a 6. When we have a problem in probability and the solution is not immediately obvious, it's always worth asking ourselves, what if the event did not occur? If we didn't get a head or a 6, what would we get? We would get not a head and not a 6. Now that could be useful. The probability of a head or a 6 is the probability that we do not get not head and not 6. Notice what I've done there. If we don't get a head and a 6, then we must get either a head or a 6. If we don't get, rather, not a head and not a 6, I should say, if that does not happen, then we do get a head or a 6. So head or a 6 is like saying either a head or a 6. And the word either means not getting neither of them. So this and suggests multiplication provided that the events are independent. And we've already seen that they are independent. So we can replace the and with a multiply. So this becomes the probability of, so the not there gives us 1 minus the probability of not h times the probability of not s. So that's 1 minus not h, 1/2, and here's where it's useful to have already done some of the groundwork before we start. Probability of not s, 5/6. We just have less to think about it this time because we've done some preparation. And that's equal to 1 minus 5 over 12. And 1 minus 5 over 12 is 7 over 12. And that's our answer here. There would be other ways to answer part D. We could have said a head or a 6 can arise by getting head and 6, or head and not 6, or not head and 6. And that would also be a valid way to answer this problem. But the approach we have taken is perhaps the shortest approach for solving this, and it's one that's worth keeping in mind. When you have an or an either, or at least one, which is what's happening here, at least one of these, a head or a 6. At least one can be a complicated event, but the opposite of at least one is none, neither. And so it can be useful to use the not approach in a case like that. So there are other problems you can try in problem set 2a.